¿Qué es la inteligencia artificial espacial? Fei-Fei Li, conocida como la madrina de la IA, acaba de recaudar cientos de millones de dólares para crear una empresa de inteligencia artificial centrada en la inteligencia espacial. En este vídeo, explicaré en qué consiste la inteligencia espacial y además veremos una entrevista con ella y la famosa firma de capital de riesgo A16Z, donde habla sobre el futuro de la inteligencia artificial, destacando que el verdadero avance será cuando las IA puedan comprender el mundo real. Primero, ¿quién es Fei-Fei Li? Es una reconocida científica computacional que ha hecho muchas contribuciones al mundo de la inteligencia artificial, con un enfoque especial y una gran pasión por la inteligencia visual, es decir, la capacidad de entender el mundo real. Jan LeCun mencionó que el lenguaje por sí solo no es suficiente para crear un modelo del mundo, lo que también se puede describir como una inteligencia artificial que comprende el mundo real. Para lograrlo, es necesario que la IA vea el mundo, y es por eso que la inteligencia espacial es tan prometedora. Antes de profundizar en su entrevista, veamos algunas de las principales contribuciones de Fei-Fei Li. Su contribución más conocida es ImageNet, un conjunto de datos visuales a gran escala lanzado en 2009. Contiene millones de imágenes etiquetadas en miles de categorías, lo que revolucionó el campo de la visión por computadora y el aprendizaje profundo. Básicamente, este conjunto de datos ayuda a las computadoras a ver el mundo real. Fei-Fei Li ha sido profesora asistente en la Universidad de Illinois, en Princeton y, más recientemente, profesora titular en la Universidad de Stanford. Sin embargo, ahora ha fundado su propia empresa, y en esta entrevista hablará sobre ello y lo que realmente hace su compañía.
Visual spatial intelligence is so fundamental. It's as fundamental as language. We've got these ingredients: compute, deeper understanding of data, and we've got some advancement of algorithms. We are in the right moment to really make a bet and to focus and just unlock that.
Over the last 2 years, we've seen this kind of massive rush of consumer AI companies and technology, and it's been quite wild. But you've been doing this now for decades. And so maybe walk through a little bit about how we got here, kind of like your key contributions and insights along the way.
So it is a very exciting moment, right? Just zooming back, AI is in a very exciting moment. Yeah. I personally have been doing this for 2 decades plus. And, we have come out of the last AI winter. We have seen the birth of modern AI. Then we have seen deep learning taking off, showing us possibilities like playing chess. But then we're starting to see the deepening of the technology and the industry adoption of some of the earlier possibilities like language models. And now I think we're in the middle of a Cambrian explosion in almost a literal sense, because now, in addition to texts, you're seeing pixels, videos, audios, all coming out with possible AI applications and models. So it's a very exciting moment.
I know you both so well, and many people know you both so well because you're so prominent in the field, but not everybody grew up in AI. So maybe it's kind of worth just going through your quick backgrounds just to kind of level set the audience.
Yeah, sure. So I first got into AI at the end of my undergrad. I did math and computer science for undergrad at Caltech. That was awesome. But then towards the end of that, there was this paper that came out that was at the time a very famous paper, the CAT paper, from Hong-Lek Lee and Andrew Ng and others that were at Google Brain at the time. And that was the first time that I came across this concept of deep learning. And to me, it just felt like this amazing technology. And that was the first time that I came across this recipe that would come to define the next more than decade of my life, which is that you can get these amazingly powerful learning algorithms that are very generic, couple them with very large amounts of compute, couple them with very large amounts of data, and magic things started to happen when you combine those ingredients. So I first came across that idea around 2011, 2012-ish, and I just thought oh my God, this is going to be what I want to do. So it was obvious you got to go to grad school to do this stuff. And then sort of saw that Fei-Fei was at Stanford, one of the few people in the world at the time who was kind of on that train. And that was just an amazing time to be in deep learning and computer vision specifically, because that was really the era when this went from these first nascent bits of technology that were just starting to work and really got developed and spread across a ton of different applications. So then over that time, we saw the beginnings of language modeling. We saw the beginnings of discriminative computer vision, where you could take pictures and understand what's in them in a lot of different ways. We also saw some of the early bits of what we would now call Gen AI, generative modeling, generating images, generating text, a lot of those core algorithmic pieces actually got figured out by the academic community during my PhD years. Like there was a time I would just like wake up every morning and check the new papers on arXiv and just be ready. It was like unwrapping presents on Christmas, that like every day, there's going to be some amazing new discovery, some amazing new application or algorithm somewhere in the world. What happened is in the last 2 years, everyone else in the world kind of came to the same realization, using AI to get new Christmas presents every day. But I think for those of us that have been in the field for a decade or more, we've sort of had that experience for a very long time.
Obviously, I'm much older than Justin. And I come to AI through a different angle, which is from physics, because my undergraduate background was physics. But physics is the kind of discipline that teaches you to think audacious questions and think about what is the remaining mystery of the world. Of course, in physics, it's atomic world, universe and all that. But somehow that kind of training thinking got me into the audacious question that really captured my own imagination, which is intelligence. So I did my PhD in AI and computational neuroscience at Caltech. So Justin and I actually didn't overlap, but we share the same alma mater at Caltech.
Oh, and the same advisor at Caltech.
Yes, same advisor, your undergraduate advisor, my PhD advisor, Pietro Perona. And my PhD time, which is similar to your PhD time, was when AI was still in the winter in the public eye. But it was not in the winter in my eye because it's that pre-spring hibernation. There's so much life. Machine learning, statistical modeling was really gaining power. And I think I was one of the native generation in machine learning and AI, whereas I look at Justin's generation is the native deep learning generation. Yeah, sure. So machine learning was the precursor of deep learning, and we were experimenting with all kinds of models. But one thing came out at the end of my PhD and the beginning of my assistant professor time. There was a overlooked elements of AI that is mathematically important to drive generalization. But the whole field was not thinking that way, and it was data. Yeah. Because we were thinking about, the intricacy of Bayesian models or whatever, kernel methods and all that. But what was fundamental that my students and my lab realized probably earlier than most people is that if you let data drive models, you can unleash the kind of power that we haven't seen before. And that was really the reason we went on a pretty crazy bet on ImageNet, which is, just forget about any scale we're seeing now, which is thousands of data points. At that point, NLP community has their own data sets. I remember UC Irvine data set or some data set in NLP it was small. Computer vision community has their data sets, but all in the order of thousands or tens of thousands. We're like, we need to drive it to internet scale. Yeah. And luckily, it was also the coming of age of internet. So we were riding that wave, and that's when I came to Stanford.
La discusión sobre el resurgimiento de la inteligencia artificial en los últimos años destaca una evolución significativa en la adopción y desarrollo de tecnologías como el aprendizaje profundo y la modelización del lenguaje. A medida que la industria ha adoptado estas innovaciones, hemos sido testigos de una verdadera explosión cámbrica en aplicaciones de IA, donde no solo los textos, sino también imágenes, vídeos y audio están siendo transformados por el potencial de la IA. Este momento es emocionante porque refleja un cambio en la forma en que se percibe y utiliza la IA en nuestra vida cotidiana. Además, el enfoque en conjuntos de datos masivos, como ImageNet, ha demostrado ser fundamental para liberar el poder de los modelos de aprendizaje automático, lo que permite avances que antes parecían inalcanzables. La combinación de grandes volúmenes de datos, algoritmos potentes y una infraestructura de computación adecuada está sentando las bases para el futuro de la IA, ofreciendo la posibilidad de resolver problemas complejos de maneras innovadoras.
So these epochs are what we often talk about. Like ImageNet is clearly the epoch that created, or at least like maybe made like popular and viable computer vision. In the Gen AI wave, we talk about two kind of core unlocks. One is like the Transformers paper, which is attention. And we talk about stable diffusion. Is that a fair way to think about this? Which is like there's these two algorithmic unlocks that came from academia or Google, and like that's where everything comes from? Or has it been more deliberate? Or have there been other kind of big unlocks that kind of brought us here that we don't talk as much about?
Yeah, I think the big unlock is compute. Like, I know the story of AI is often the story of compute, but even no matter how much people talk about it, I think people underestimate it, right? And the amount of growth that we've seen in computational power over the last decade is astounding. The first paper that's really credited with the breakthrough moment in computer vision for deep learning was AlexNet, which was a 2012 paper where a deep neural network did really well on the ImageNet challenge, and just blew away all the other algorithms that Fei-Fei had been working on, and the types of algorithms that you'd been working on more in grad school. That AlexNet was a 60 million parameter deep neural network, and it was trained for 6 days on 2 GTX 580s, which was the top consumer card at the time, which came out in 2010. So I was looking at some numbers last night just to, put these in perspective. The latest and greatest from NVIDIA is the GB200. Do either of you want to guess how much raw compute factor we have between the GTX 580 and the GB200?
Shoot, no. What?
Go for it.
It's in the thousands. So I ran the numbers last night, like that 2-week training run, that of 6 days on 2 GTX 580s. If you scale
Seconds.
It comes out to just under 5 minutes.
Wow.
On a single GB200.
Wow.
Justin is making a really good point. The 2012 AlexNet paper on ImageNet challenge is literally a very classic model. And that is the convolutional neural network model. And that was published in 1980s, the first paper. I remember as a graduate student learning that. And it more or less also has 6-7 layers. Practically the only difference between AlexNet and the ConvNet, what's the difference is the GPUs, the 2 GPUs, and the deluge of data.
La potencia computacional es crucial para el avance de la inteligencia artificial, especialmente en visión por computadora. El hito de AlexNet en 2012, que utilizó una red neuronal profunda de 60 millones de parámetros entrenada en 2 GPUs GTX 580, marcó un punto de inflexión al superar a otros algoritmos en el desafío de ImageNet. Desde entonces, la mejora en la capacidad de procesamiento ha sido exponencial. Por ejemplo, un entrenamiento que antes tomaba 6 días en las GTX 580 ahora puede completarse en menos de 5 minutos con la última generación de GPUs, como la A100 de NVIDIA. Esta evolución ha permitido el desarrollo de modelos más complejos y potentes, evidenciando que el poder computacional es un elemento esencial en el progreso de la IA.
Well, so that's what I was going to go, which is like, so I think most people now are familiar with like, quote, the bitter lesson. And the bitter lesson says is if you make an algorithm, don't be cute.
Yeah.
Just make sure you can take advantage of available compute, because the available compute will show up, right? And so like, you just like need to like wive like the... On the other hand, there's another narrative, which seems to me to be like just as credible, which is like, it's actually new data sources that unlock deep learning, right? Like ImageNet is a great example, but like a lot of people, like self-attention is great from transformers, but they'll also say this is a way you can exploit human labeling of data because like it's the humans that put the structure in the sentences. And if you look at CLIP, they'll say, well, like we're using the internet to like actually like have humans use the alt tag to label images, right? And so like that's a story of data, that's not a story of compute. And so is the answer just both, or is like one more than the other? Or
I think it's both, but you're hitting on another really good point. So I think there's actually 2 epochs that to me feel quite distinct in the algorithmics here. So like the ImageNet era is actually the era of supervised learning. So in the era of supervised learning, you have a lot of data, but you don't know how to use data on its own. Like the expectation of ImageNet and other data sets of that time period was that we're going to get a lot of images, but we need people to label every one. And all of the training data that we're going to train on, like a human labeler has looked at every one and said something about that image. And the big algorithmic unlocks, we know how to train on things that don't require human labeled data.
As the naive person in the room that doesn't have an AI background, it seems to me if you're training on human data, like the humans have labeled it, it's just not explicit.
I knew you were going to say that, Martin. I knew that.
Right? I mean,
yes, philosophically, that's a really important question. But that actually is more true in language than pixels.
Fair enough. Yeah. 100%.
Right.
Yeah. But I do think it's an important distinction because clip really is human labeled. I think intention is humans have like figured out the relationships of things and then you learn them. So it is human labeled, just more implicit than explicit.
Yeah, it's still human labeled. The distinction is that for this supervised learning era, our learning tasks were much more constrained. So like you would have to come up with this ontology of concepts that we want to discover, right? If you're doing in ImageNet, like Fei-Fei and your students at the time spent a lot of time thinking about, which 1,000 categories should be in the ImageNet challenge. The other data sets of that time, like the COCO data set for object detection, like they thought really hard about which 80 categories we put in there.
So let's walk to Gen AI. So when I was doing my PhD before that you came, so I took machine learning from Andrew Ng, and then I took like Bayesian, something very complicated from Daphne Koller, and it was very complicated for me. And a lot of that was just predictive modeling.
Yep.
And then like I remember the whole kind of vision stuff that you unlocked, but then the generative stuff has shown up, like I would say in the last 4 years, which is to me very different. Like you're not identifying objects, you're not, predicting something, you're generating something. And so maybe kind of walk through like the key unlocks that got us there and then why it's different and if we should think about it differently and is it part of a continuum, is it not?
It is so interesting. Even during my graduate time, generative model was there. We wanted to do generation. Nobody remembers, even with letters and numbers, we were trying to do some, Jeff Hinton has had generated papers. We were thinking about how to generate. And in fact, if you think from a probability distribution point of view, you can mathematically generate. It's just nothing we generate would ever impress anybody, right? So this concept of generation mathematically, theoretically is there, but nothing worked. So then I do want to call out Justin's PhD. And Justin was saying that he got enamored by deep learning, so he came to my lab. Justin's PhD, his entire PhD is a story, almost a mini story of the trajectory of the field. He started his first project in data. I forced him to. He didn't like it. So
in retrospect, I learned a lot of really useful things.
I'm glad you say that now. So we moved Justin to deep learning, and the core problem there was taking images and generating words.
Well, actually, it was even about, I think there were 3 discrete phases here on this trajectory.
Okay.
So the first one was actually matching images and words.
Right.
Like we have an image, we have words, and can we say how much they align? So actually, my first paper, both of my PhD and like ever, my first academic publication ever, was the image retrieval with scene graphs.
And then we went into the taking pixels, generating words, and Justin and Andre really worked on that. But that was still a very, very lossy way of generating and getting information out of the pixel world. And then in the middle, Justin went off and did a very famous piece of work. And it was the first time that someone made it real time. Right.
Yeah. So the story there is there was this paper that came out in 2015, a neural algorithm of artistic style led by Leon Gaddis. And it was like the paper came out and they showed like these real world photographs that they had converted into Van Gogh style. And like we are kind of used to seeing things like this in 2024, but this was in 2015. Yeah. So this paper just popped up on arXiv one day and it like blew my mind. Like I just got this like Gen AI brainworm like in my brain in like 2015 and it like did something to me. And I thought like, oh my God, I need to understand this algorithm. I need to play with it. I need to make my own images into Van Gogh. Yeah. So then I like read the paper and then over a long weekend, I re-implemented the thing and got it to work. It was a very simple algorithm. So like my implementation was like 300 lines of Lua, because at the time it was Lua.
Wow.
So there was this was pre-PyTorch, so we were using Lua Torch. But it was like very simple algorithm, but it was slow, right? So it was an optimization based thing. Every image you want to generate, you need to run this optimization loop, run this gradient descent loop for every image that you generate. The images were beautiful, but I just like wanted it to be faster.
and Justin just did it, and it was actually, I think, your first taste of an academic work having an industry impact.
A bunch of people had seen this this artistic style transfer stuff at the time, and me and a couple others at the same time came up with different ways to speed this up.
Yeah.
But mine was the one that got a lot of traction.
Right. So I was very proud of Justin. But there's one more thing I was very proud of Justin to connect to Gen AI, is that before the world understand Gen AI, Justin's last piece of work in PhD, which I I knew about it because I was forcing you to do it.
That one was fun.
Yes,
that one a lot.
was actually inputting language and getting a whole picture out. It's one of the first Gen AI work. It's using GAN, which was so hard to use. But the problem is that we are not ready to use a natural piece of language. So Justin, you heard he worked on scene graph. So we have to input a scene graph language structure. Yeah. So, the sheep, the grass, the sky in a graph way. It literally was one of our photos, right? Yeah. And then he and another very good master student, Grim, they got that again to work. So you can see from data to matching to style transfer to generative images, we're starting to see, you ask if this is a abrupt change. For people like us, it's already happening in a continuum. Right. But for the world, it's more the results are more abrupt.
La discusión aborda la interdependencia entre datos y poder computacional en el desarrollo de algoritmos de aprendizaje profundo, destacando la lección amarga, que sugiere que el enfoque debe estar en aprovechar el poder computacional disponible. Aunque la era de ImageNet representó un avance en el aprendizaje supervisado, donde los datos requerían etiquetado humano, la evolución hacia modelos generativos ha permitido utilizar datos de manera más implícita. Se identifican 3 fases clave en este proceso: coincidencia entre imágenes y palabras, generación de palabras a partir de imágenes y, finalmente, la creación de imágenes en tiempo real, ejemplificada por la transferencia de estilo artístico. Este cambio refleja un continuo en la IA, donde la combinación de datos y potencia computacional impulsa resultados más sofisticados.
So I read your book, and for those that are listening, it's a phenomenal book. I really recommend you read it. And it seems for a long time, like a lot of and I'm talking to you, Fei-Fei, like a lot of your research has been, and your direction has been towards kind of spatial stuff and pixel stuff and intelligence. And now you're doing World Labs, and it's around spatial intelligence. And so maybe talk through has this been part of a long journey for you? Like, why did you decide to do it now? Is it a technical unlock? Is it a personal unlock? Just kind of move us from that kind of milieu of AI research to World Labs.
Sure. For me, it is both personal and intellectual, right? You talk about my book, my entire intellectual journey is really this passion to seek North Stars, but also believing that those North Stars are critically important for the advancement of our field. So at the beginning, I remembered after graduate school, I thought my North Star was telling stories of images, because for me, that's such an important piece of visual intelligence. That's part of what you call AI or AGI. But when Justin and Andre did that, I was like, oh my God, that was my live stream. What do I do next? So it came a lot faster. I thought it would take 100 years to do that. So, but visual intelligence is my passion, because I do believe for every intelligent being, like people or robots or some other form, knowing how to see the world, reason about it, interact in it, whether you're navigating or manipulating or making things, you can even build civilization upon it. Visual spatial intelligence is so fundamental.
Fei-Fei Li reflexiona su trayectoria en el campo de la inteligencia artificial, destacando su pasión por la inteligencia visual y cómo ha evolucionado hacia el trabajo en inteligencia espacial en World Labs. Habla de su búsqueda de estrellas del norte en la investigación, subrayando la importancia de entender cómo los seres inteligentes interactúan con su entorno, un aspecto esencial para el desarrollo de la inteligencia artificial y la inteligencia artificial general. Además, menciona que su enfoque inicial en contar historias a través de imágenes fue influenciado por los logros de otros investigadores, lo que refleja su capacidad de adaptarse a las dinámicas del campo. En términos técnicos, resalta que la inteligencia visual es un componente clave para el avance de la IA, sugiriendo que comprenderla puede ser fundamental no solo para crear nuevas tecnologías, sino también para construir civilizaciones en el futuro.
It's as fundamental as language, possibly more ancient and more fundamental in certain ways. So it's very natural for me that World Labs is our North Star is to unlock spatial intelligence. The moment to me is right to do it, like Justin was saying, compute. We've got these ingredients. We've got compute. We've got a much deeper understanding of data, way deeper than ImageNet days, compared to those days, we're so much more sophisticated. And we've got some advancement of algorithms, including co-founders in World Lab like Ben Mildenhall and Christoph Lasner. They were at the cutting edge of nerve that we are in the right moment to really make a bet and to focus and just unlock that.
Great. So I just want to clarify for folks that are listening to this, which is, so, you're starting this company, World Labs, spatial intelligence is kind of how you're generally describing the problem you're solving. Can you maybe try to crisply describe what that means?
Yeah, so spatial intelligence is about machines' ability to perceive, reason, and act in 3D space and time, to understand how objects and events are positioned in 3D space and time, how interactions in the world can affect those 4D positions over space-time, and both sort of perceive, reason about, generate, interact with, really take the machine out of the mainframe or out of the data center and putting it out into the world and understanding the 3D, 4D world with all of its richness.
So to be very clear, are we talking about the physical world, or are we just talking about an abstract notion of world?
I think it can be both. I think it can be both, and that encompasses our vision long-term.
Yeah.
Even if you're generating worlds, even if you're generating content, doing that positioned in 3D with 3D has a lot of benefits. Or if you're recognizing the real world, being able to put 3D understanding into the real world as well is part of it.
Great. So, I mean, just for everybody listening, like the two other co-founders, Ben Mildenhall and Christoph Lasner, are absolute legends in the field at the same level. These four decided to come out and do this company now, and so I'm trying to dig to like why now is the right time.
Yeah, I mean, this is, again, part of a longer evolution for me, but like really after PhD, when I was really wanting to develop into my own independent researcher, both for my later career, I was just thinking, what are the big problems in AI and computer vision? And the conclusion that I came to about that time was that the previous decade had mostly been about understanding data that already exists. But the next decade was going to be about understanding new data. And if we think about that, the data that already exists was all of the images and videos that maybe existed on the web already. And the next decade was going to be about understanding new data, right? Like people have smartphones. Smartphones are collecting cameras. Those cameras have new sensors. Those cameras are positioned in the 3D world. It's not just you're going to get a bag of pixels from the internet and know nothing about it and try to say if it's a cat or a dog. We want to treat images as universal sensors to the physical world. And how can we use that to understand the 3D and 4D structure of the world, either in physical spaces or generative spaces? So I made a pretty big pivot post-PhD into 3D computer vision, predicting 3D shapes of objects with some of my colleagues at FAIR at the time. Then later, I got really enamored by this idea of learning 3D structure through 2D, right? Because we talk about data a lot. 3D data is hard to get on its own, but because there's a very strong mathematical connection here, our 2D images are projections of a 3D world. And there's a lot of mathematical structure here we can take advantage of. So even if you have a lot of 2D data, there's a lot of people who've done amazing work to figure out how can you back out the 3D structure of the world from large quantities of 2D observations. And then in 2020, you asked about breakthrough moments. There was a really big breakthrough moment from our co-founder, Ben Mildenhall at the time with his paper NERF, neural radiance fields.
Great.
And that was a very simple, very clear way of backing out 3D structure from 2D observations. That just lit a fire under this whole space of 3D computer vision. Mm-hmm. I think there's another aspect here that maybe people outside the field don't quite understand. That was also a time when large language models were starting to take off.
Yep.
So a lot of the stuff with language modeling actually had gotten developed in academia. Even during my PhD, I did some early work with Andrei Karpathy on language modeling in 2014.
LSTM, I still remember.
LSTMs, RNNs, GRUs,
yes.
like this was pre-transformer. But then at some point, around the GPT-2 time, you couldn't really do those kind of models anymore in academia because they took a way more resourcing. Yeah. But there was one really interesting thing: the NERF approach that Ben came up with. You could train these in an hour, a couple hours on a single GPU. So I think at that time, like there was a dynamic here that happened, which is that I think a lot of academic researchers ended up focusing a lot of these problems because there was core algorithmic stuff to figure out, and because you could actually do a lot without a ton of compute, and you could get state-of-the-art results on a single GPU. Because of those dynamics, there was a lot of researchers in academia were moving to think about what are the core algorithmic ways that we can advance this area as well. Then I ended up chatting with Fei-Fei more, and I realized that we were actually...
She's very convincing.
She's very convincing. Well, there's that, but like, you know, you were talking about trying to like figure out your own independent research trajectory from your advisor. Well, it turns out we had ended up kind of concluding converging on similar things.
Okay, well, from my end, I want to talk to the smartest person. I call Justin. There's no question about it. I do want to talk about a very interesting technical issue or technical story of pixels that most people working in language don't realize is that pre-Gen AI era in the field of computer vision, those of us who work on pixels, we actually have a long history in an area of research called reconstruction, 3D reconstruction, which is, you know, it dates back from the 70s. You know, you can take photos because humans have two eyes, right? So in general, it starts with stereo photos, and then you try to triangulate the geometry and make a 3D shape out of it. It is a really, really hard problem. To this day, it's not fundamentally solved because there's correspondence and all that. And then so this whole field, which is an older way of thinking about 3D, has been going around and it has been making really good progress. But when NeRF happened in the context of generative methods, in the context of diffusion models, suddenly reconstruction and generation start to really merge. In now, like within really a short period of time in the field of computer vision, it's hard to talk about reconstruction versus generation anymore. We suddenly have a moment where if we see something or if we imagine something, both can converge towards generating it.
Right.
And that's just, to me, a really important moment for computer vision, but most people missed it because we're not talking about it as much.
La inteligencia espacial se ha vuelto crucial en el desarrollo de la inteligencia artificial, ya que permite a las máquinas entender y actuar en un entorno tridimensional, tanto en el mundo físico como en espacios generativos. Este enfoque se fundamenta en el avance de algoritmos y modelos que aprovechan la enorme cantidad de datos 2D, como imágenes y vídeos, para inferir estructuras 3D. Un ejemplo clave es el desarrollo de métodos como NERF, que han revolucionado la reconstrucción 3D, integrando la generación y la percepción de manera más fluida. Este avance, combinado con el acceso a computación más potente y la evolución de los modelos de lenguaje, abre nuevas posibilidades para comprender y modelar el mundo de manera más rica y efectiva. La fusión de la visión por computadora con la generación de contenido representa un hito importante en el campo, permitiendo a los investigadores abordar problemas complejos de una manera que antes no era posible.
Right.
LLMs.
Right. So in pixel space, there's reconstruction where you reconstruct like a scene that's real, and then if you don't see the scene, then you use generative techniques, right? So these things are kind of very similar. Throughout this entire conversation, you're talking about languages and you're talking about pixels. So maybe it's a good time to talk about how like spatial intelligence and what you're working on contrasts with language approaches, which of course are very popular now. Like, is it complementary? Is it orthogonal?
Yeah, I think they're complementary.
I don't mean to be too leading here. Like, maybe just contrast them. Like, everybody says, like, listen, I know OpenAI and I know GPT and I know multimodal models, and a lot of what you're talking about is like they've got pixels and they've got languages, and like, doesn't this kind of do what we want to do with spatial reasoning?
Yeah, so I think to do that, you need to open up the black box a little bit of how these systems work under the hood. So with language models and the multimodal language models that we're seeing nowadays, their underlying representation under the hood is a one-dimensional representation.
Yeah.
We talk about context lengths, we talk about transformers, we talk about sequences.
Attention.
Yeah. Fundamentally, their representation of the world is one-dimensional. So these things fundamentally operate on a one-dimensional sequence of tokens. So this is a very natural representation when you're talking about language, because written text is a one-dimensional sequence of discrete letters. So that kind of underlying representation is the thing that led to LLMs. And now the multimodal LLMs that we're seeing now, you kind of end up shoehorning the other modalities into this underlying representation of a 1D sequence of tokens.
Yeah.
Now, when we move to spatial intelligence, it's kind of going the other way, where we're saying that the three-dimensional nature of the world should be front and center in the representation. So at an algorithmic perspective, that opens up the door for us to process data in different ways, to get different kinds of outputs out of it, and to tackle slightly different problems. So even at a course level, you kind of look at outside and you say, oh, multimodal LLMs can look at images too. Well, they can, but I think that they don't have that fundamental 3D representation at the heart of their approaches.
I totally agree with Justin. I think talking about the 1D versus fundamentally 3D representation is one of the most core differentiation. The other thing is a slightly philosophical, but it's really important for me at least, is language is fundamentally a purely generated signal. There's no language out there. You don't go out in the nature and there's words written in the sky for you. Whatever data you feed in, you pretty much can just somehow regurgitate with enough generalizability the same data out. And that's language to language. But 3D world is not. There is a 3D world out there that follows laws of physics, that has its own structures due to materials and many other things. And to fundamentally back that information out and be able to represent it and be able to generate it is just fundamentally quite a different problem. We will be borrowing similar ideas or useful ideas from language and LLMs, but this is fundamentally philosophically to me a different problem.
Right.
Lo que se discutió fue una comparación bastante técnica entre los modelos de inteligencia espacial y los enfoques basados en lenguaje en la IA. El énfasis estuvo en cómo los modelos de lenguaje y multimodales actuales se apoyan en representaciones unidimensionales, secuencias de tokens, lo cual encaja de manera natural con el texto escrito. Sin embargo, para la inteligencia espacial, el enfoque cambia, ya que se necesita una representación en 3D del mundo, lo que plantea un desafío distinto, ya que los objetos en el espacio físico siguen leyes de la física y tienen estructuras propias. Mientras que el lenguaje es un sistema generado y simbólico, la representación del mundo 3D es una realidad tangible que exige un tratamiento completamente diferente a nivel algorítmico y conceptual.
So language, 1D, and probably a bad representation of the physical world because it's been generated by humans and is probably lossy. There's a whole nother modality of generative AI models, which are pixels. And these are 2D image and 2D video. And like one could say that like if you look at a video, it looks, you know, you can see 3D stuff because like you can pan a camera or whatever it is. And so like how would like spatial intelligence be different than say 2D video?
Here, when I think about this, it's useful to disentangle two things. One is the underlying representation, and then two is kind of the user-facing affordances that you have.
Yeah.
And here's where you can get sometimes confused because fundamentally we see 2D, right? Like our retinas are 2D structures in our bodies, and we've got two of them. So like fundamentally our visual system perceives 2D images. But the problem is that depending on what representation you use, there could be different affordances that are more natural or less natural. So even if you are, at the end of the day, you might be seeing a 2D image or a 2D video, your brain is perceiving that as a projection of a 3D world. So there's things you might want to do, like move objects around, move the camera around. In principle, you might be able to do these with a purely 2D representation and model, but it's just not a fit to the problems that you're asking the model to do. Right? Like modeling the 2D projections of a dynamic 3D world is a function that probably can be modeled. But by putting a 3D representation into the heart of a model, there's just going to be a better fit between the kind of representation that the model is working on and the kind of tasks that you want that model to do. So our bet is that by threading a little bit more 3D representation under the hood, that'll enable better affordances for users.
And this also goes back to the North Star. For me, you know, why is it spatial intelligence? Why is it not flat pixel intelligence? Is because I think the arc of intelligence has to go to what Justin calls affordances. And the arc of intelligence, if you look at evolution, right, the arc of intelligence eventually enables animals and humans, especially human as an intelligent animal, to move around the world, interact with it, create civilization, create life, create a piece of sandwich, whatever you do in this 3D world. And and translating that into a piece of technology, that native 3D-ness is fundamentally important for the floodgate of possible applications,
right.
Even if some of them, the serving of them looks 2D, but it's innately 3D.
Lo que se exploró fue la diferencia entre cómo los modelos de inteligencia espacial y los enfoques basados en imágenes 2D o vídeos abordan la percepción del mundo físico. Aunque nuestros ojos perciben imágenes en 2D, nuestra mente interpreta esa información como una proyección de un mundo en 3D. La idea central es que, aunque las representaciones en 2D pueden simular un entorno tridimensional, un modelo que tenga una representación 3D en su núcleo será más adecuado para resolver problemas del mundo real. La inteligencia espacial se enfoca en esa capacidad de interactuar y moverse en un espacio tridimensional, lo que tiene un potencial enorme en términos de aplicaciones tecnológicas, como lo vemos en la evolución misma de la inteligencia en seres vivos.
To me.
I think this is actually very subtle.
Yeah.
An incredibly critical point. And so I think it's worth digging into. And a good way to do this is talking about use cases. And so just to level set this, so we're talking about generating a technology, let's call it a model, that can do spatial intelligence. So maybe in the abstract, what might that look like kind of a little bit more concretely? What would be the potential use cases that you could apply this to?
So I think there's a couple different kinds of things we imagine these spatially intelligent models able to do over time. And one that I'm really excited about is world generation. We're all used to something like a text-to-image generator, or starting to see text-to-video generators, where you put in an image, put in a video, and out pops an amazing image or an amazing 2-second clip. But I think you could imagine leveling this up and getting 3D worlds out. So one thing that we could imagine spatial intelligence helping us with in the future are up-leveling these experiences into 3D, where we're not getting just an image out or just a clip out, but you're getting out a full simulated but vibrant and interactive 3D world.
For gaming?
Maybe for gaming, right? Maybe for gaming, maybe for virtual photography, like you name it. There's even if you got this to work, there'd be a million applications.
For education.
Yeah, for education.
Right.
I mean, I guess one of my things is that, like, we, in some sense, this enables a new form of media, right? Because we already have the ability to create virtual interactive worlds, but it costs hundreds of millions of dollars and a ton of development time. And as a result, like, what are the places that people drive this technological ability is video games, right? Because if we do have the ability as a society to create amazingly detailed virtual interactive worlds that give you amazing experiences, but because it takes so much labor to do so, then the only economically viable use of that technology in its form today is games that can be sold for $70 a piece to millions and millions of people to recoup the investment. If we had the ability to create these same virtual, interactive, vibrant 3D worlds, you could see a lot of other applications of this, right? Because if you bring down that cost of producing that kind of content, then people are going to use it for other things. What if you could have sort of a personalized 3D experience that's as good and as rich, as detailed as one of these AAA video games that cost hundreds of millions of dollars to produce, but it could be catered to, like, this very niche thing that only maybe a couple people would want that particular thing. That's not a particular product or a particular roadmap, but I think that's a vision of a new kind of media that would be enabled by spatial intelligence in the generative realms.
Aquí se discutió el potencial de los modelos de inteligencia espacial para revolucionar la creación de mundos inmersivos en 3D. La idea es que, si bien actualmente generamos imágenes o vídeos a partir de texto, el siguiente nivel sería la creación de mundos tridimensionales completos, interactivos y vibrantes, con aplicaciones que podrían ir más allá de los videojuegos. La capacidad de generar estos entornos virtuales a menor costo permitiría su uso en áreas como la educación y nuevas formas de medios personalizados, que hoy en día son demasiado costosos y laboriosos de producir. La inteligencia espacial promete democratizar la creación de experiencias interactivas detalladas que, hasta ahora, solo grandes producciones de videojuegos pueden ofrecer.
When I think about a world, I actually think about things that are not just scene generation. I think about stuff like movement and physics. And so like in the limit, is that included? And then the second one
Absolutely.
is, if I'm interacting with it, like, are there semantics? And I mean by that, like, if I open a book, are there like pages and are there words in it? And do they mean like, are we talking like a full depth experience, or are we talking about like kind of a static scene?
I think we'll see a progression of this technology over time. This is really hard stuff to build.
Yeah.
So I think the static problem is a little bit easier. But in the limit, I think we want this to be fully dynamic, fully interactable, all the things that you just said.
Yeah.
I mean, that's the definition of spatial intelligence.
Exactly.
Yeah. So there is going to be a progression. We'll start with more static, but everything you've said is in the roadmap of spatial intelligence.
I mean, this is kind of in the name of the company itself, World Labs. Like the world is about building and understanding worlds. And like this is actually a little bit of inside baseball. I realized after we told the name to people, they don't always get it because in computer vision and reconstruction and generation, we often make a distinction or a delineation about the kinds of things you can do. And kind of the first level is objects, right? Like a microphone, a cup, a chair. Like these are discrete things in the world. And a lot of the ImageNet style stuff that Fei-Fei worked on was about recognizing objects in the world. Then leveling up the next level of objects, I think of as scenes. Like scenes are compositions of objects. Like now we've got this recording studio with a table and microphones and people in chairs. It's some composition of objects. But then like we envision worlds as a step beyond scenes, right? Like scenes are kind of maybe individual things, but we want to break the boundaries, go outside the door, like step up from the table, walk out from the door, walk down the street and see the cars buzzing past and see like the leaves on the trees moving and be able to interact with those things.
Another thing that's really exciting is just to mention the word new media. With this technology, the boundary between real world and virtual imagined world or augmented world or predicted world is all blurry. You really, the real world is 3D, right? So in the digital world, you have to have a 3D representation to even blend with the real world. You know, you cannot have a 2D, you cannot have a 1D to be able to interface with the real 3D world in an effective way. And with this, it unlocks it. So the use cases can be quite limitless because of this.
Right.
En esta conversación se destacó la evolución de la tecnología de inteligencia espacial, donde el objetivo es pasar de la generación de escenas estáticas a mundos dinámicos e interactivos. Aunque el enfoque inicial se centrará en la creación de entornos estáticos, la visión a largo plazo implica la simulación completa de un entorno con movimiento, física y semántica, es decir, que los objetos en esos mundos tengan funciones y significados propios, como un libro con páginas y palabras legibles. La diferencia clave está en avanzar desde la simple identificación de objetos y escenas a crear mundos completos, donde el usuario pueda moverse e interactuar de manera fluida. Esta tecnología borra la línea entre el mundo real y el virtual, ya que una representación tridimensional será fundamental para lograr una integración coherente con el entorno físico, lo que abre posibilidades casi ilimitadas para nuevos medios y aplicaciones.
So the first use case that Justin was talking about would be like the generation of a virtual world for any number of use cases. The one that you're just alluding to would be more of an augmented reality, right?
Yes, just around the time World Lab was being formed, Vision Pro was released by Apple, and they used the word spatial computing. They almost stole our but we're spatial intelligence. So spatial computing needs spatial intelligence. That's exactly right. So we don't know what hardware form it will take. It'll be goggles, glasses,
Contact
lenses. But that interface between the true real world and what you can do on top of it, whether it's to help you to augment your capability to work on a piece of machine and fix your car, even if you are not a trained mechanic, or to just be in Pokemon Go plus for entertainment. Suddenly, this piece of technology is going to be the operating system, basically, for AR, VR, MixR.
In the limit, like what does an AR device need to do? It's this thing that's always on, it's with you, it's looking out into the world, so it needs to understand the stuff that you're seeing and maybe help you out with tasks in your daily life. But I'm also really excited about this blend between virtual and physical that becomes really critical. If you have the ability to understand what's around you in real time in perfect 3D, then it actually starts to deprecate large parts of the real world as well. Like right now, how many differently sized screens do we all own for different use cases?
Too many.
Yeah,
right? You've got your phone, you've got your iPad, you've got your computer monitor, you've got your TV,
Watch.
you've got your watch. Like these are all basically different size screens because they need to present information to you in different contexts and in different positions. But if you've got the ability to seamlessly blend virtual content with the physical world, it kind of deprecates the need for all of those. It just ideally seamlessly blends the information that you need to know in the moment with the right mechanism of giving you that information.
Totally.
Another huge case of being able to blend the digital virtual world with the 3D physical world is for alien agents to be able to do things in the physical world. And if humans use this mixed art devices to do things, like I said, I don't know how to fix a car, but if I have to, I put on this goggle or glass and suddenly I'm guided to do that. But there are other types of agents, namely robots. Alien kind of robots, so not just humanoid. And their interface, by definition, is the 3D world. But their compute, their brain, by definition, is the digital world. Okay. So what connects that from the learning to behaving between a robot brain to the real world brain? It has to be spatial intelligence.
So you've talked about
En esta conversación se destacó la importancia de la inteligencia espacial en el futuro de la realidad aumentada AR y la realidad virtual VR. La inteligencia espacial es vista como un componente esencial para el funcionamiento de estos sistemas, ya que permitirá una interacción fluida entre el mundo físico y el virtual. Se habló sobre cómo dispositivos como gafas o lentes de contacto podrían utilizar esta tecnología para ayudarnos en tareas cotidianas, como reparar un coche sin conocimientos previos, o para entretenimiento, como en juegos de realidad aumentada. Además, se mencionó que la capacidad de mezclar de manera perfecta el contenido digital con el mundo físico eliminaría la necesidad de múltiples pantallas físicas que usamos hoy en día. También se exploró cómo esta tecnología podría beneficiar a robots y otros agentes autónomos, que, al igual que los humanos, necesitan interactuar con el mundo tridimensional pero con un cerebro digital, lo que requiere una comprensión avanzada del entorno a través de la inteligencia espacial.
Virtual world, you've talked about kind of more of an augmented reality, and now you've just talked about the purely physical world, basically, which would be used for robotics. For any company, that would be like a very large charter, especially if you're going to get into each one of these different areas. So how do you think about the idea of like deep tech versus any of these specific application areas?
We see ourselves as a deep tech company, as the platform company that provides models that can serve different use cases.
Of these three, is there any one that you think is kind of more natural early on that people can kind of expect the company to lean into? Or is it...
I think it suffices to say the devices are not totally ready.
Actually, I got my first VR headset in grad school. And just like, that's one of these transformative technology experiences. You put it on, you're like, oh my God, like this is crazy. And I think a lot of people have that experience the first time they use VR. So I've been excited about this space for a long time. And I love the Vision Pro. Like I stayed up late to order one of the first ones, like the first day it came out. But I think the reality is it's just not there yet as a platform for mass market appeal.
So very likely as a company, we'll move into a market that's more ready than...
Then I think there can sometimes be simplicity and generality, right? Like if we have this notion of being a deep tech company, we believe that there is some underlying fundamental problems that need to be solved really well, and if solved really well, can apply to a lot of different domains. We really view this long arc of the company as building and realizing the dreams of spatial intelligence writ large.
So this is a lot of technology to build, it seems to me.
Yeah, I think it's a really hard problem. I think sometimes from people who are not directly in the AI space, they just see it as like AI as one undifferentiated mass of talent.
Yep.
And for those of us who have been here for longer, you realize that there's a lot of different kinds of talent that need to come together to build anything in AI, in particular this one. We've talked a little bit about the data problem. We've talked a little bit about some of the algorithms that I worked on during my PhD, but there's a lot of other stuff we need to do this too. You need really high quality, large scale engineering. You need really deep understanding of the 3D world. There's actually a lot of connections with computer graphics because they've been kind of attacking a lot of the same problems from the opposite direction. So when we think about team construction, we think about how do we find absolute top of the world, best experts in the world at each of these different subdomains that are necessary to build this really hard thing.
When I thought about how we form the best founding team for World Labs, it has to start with a group of phenomenal multidisciplinary founders. Yeah. And of course, Justin is natural for me. Justin cover your years as one of my best students and one of the smartest technologists. But there are two other people I have known by reputation, and one of them Justin even worked with, that I was drooling for, right? One is Ben Mildenhall. We talked about his seminal work in Nerve. But another person is Christoph Lassner, who has been reputed in the community of computer graphics, and especially he had the foresight of working on a precursor of the Gaussian splat representation for 3D modeling 5 years, right, before the Gaussian splat takeoff. And when we talk about the potential possibility of working with Christoph Lassner, Justin just jumped off his chair.
En esta conversación se aborda cómo una empresa de tecnología profunda, como World Labs, enfrenta el reto de desarrollar modelos avanzados que puedan servir para una amplia gama de aplicaciones, desde realidad virtual VR y aumentada AR hasta robótica en el mundo físico. Aunque estas tecnologías tienen gran potencial, actualmente no están completamente listas para el mercado masivo, como se menciona con ejemplos como el Vision Pro de Apple. La compañía se ve a sí misma como una plataforma que se enfoca en resolver problemas fundamentales de la inteligencia espacial, aplicables a múltiples sectores. También se destaca la importancia de reunir a un equipo multidisciplinario de expertos, provenientes de campos como la inteligencia artificial, gráficos por computadora y modelado 3D, para abordar los desafíos técnicos complejos. La conversación menciona a figuras clave en la industria, destacando la necesidad de contar con los mejores talentos en áreas específicas para avanzar en este ambicioso proyecto.
Ben and Christoph are legends, and maybe just quickly talk about kind of like how you thought about the build out of the rest of the team, because again, like it's, there's a lot to build here and a lot to work on, not just in kind of AI or graphics, but like systems and so forth.
Yeah. This is what so far I'm personally most proud of, is the formidable team. I've had the privilege of working with the smartest young people in my entire career, right? From the top universities, being a professor at Stanford. But the kind of talent that we put together here at World Labs is just phenomenal. I've never seen the concentration. And I think the biggest differentiating element here is that we're believers of spatial intelligence. All of the multidisciplinary talents, whether it's system engineering, machine learning infra, to, generative modeling, to data, to, graphics, all of us, whether it's our personal research journey or technology journey or even personal hobby, we believe that spatial intelligence has to happen at this moment with this group of people. And that's how we really found our founding team. And that focus of energy and talent is really just humbling to me. I just love it.
En esta sección, se destaca la importancia de construir un equipo excepcional en World Labs, donde el enfoque en la inteligencia espacial es un valor compartido por todos los miembros. Expresa su orgullo por haber reunido a un grupo de jóvenes talentos provenientes de las mejores universidades, lo que ha permitido concentrar habilidades en áreas como la ingeniería de sistemas, aprendizaje automático, modelado generativo y gráficos. Este equipo multidisciplinario no solo se compone de expertos en sus campos, sino que también comparte una pasión personal por la inteligencia espacial, lo que refuerza su compromiso colectivo para llevar a cabo esta visión en un momento crucial para la tecnología. La dedicación y energía del equipo son consideradas como elementos fundamentales en el desarrollo del proyecto.
So I know you've been guided by a North Star. So something about North Stars is like you can't actually reach them because they're in the sky, but it's a great way to have guidance. So how will you know when you've accomplished what you've set out to accomplish? Or is this a lifelong thing that's going to continue kind of infinitely?
First of all, there's real North Stars and virtual North Stars. Oh, yeah. Sometimes you can reach virtual North Stars.
Fair enough. Good enough.
Like
in the world model.
Exactly.
You can hit the North Star.
Like I said, I thought one of my North Star that would take 100 years was storytelling of images, and Justin and Andre, in my opinion, solved it for me.
Great.
So we could get to our North Star. But I think for me is when so many people and so many businesses are using our models to unlock their needs for spatial intelligence. And that's the moment I know we have reached a major milestone.
Actual deployment, actual impact, actual use.
Yeah, I don't think we're ever going to get there. I think that this is such a fundamental thing. Like, the universe is a giant, evolving, four-dimensional structure. 100%. And spatial intelligence writ large is just understanding that in all of its depths and figuring out all the applications to that. So I think that we have a particular set of ideas in mind today, but I think this journey is going to take us places that we can't even imagine right now.
The magic of good technology is that technology opens up more possibilities and unknowns. So we will be pushing, and then the possibilities will be expanding.
Brilliant. Thank you, Justin. Thank you, Fei-Fei. This was fantastic.
Thank you, Martin.
En esta parte, se discute el concepto de estrella del norte, en el contexto de la inteligencia espacial y cómo se mide el éxito en este campo. Fei-Fei Li, la fundadora, señala que, aunque las North Stars pueden parecer inalcanzables, sirven como una guía esencial en el proceso de desarrollo. Para ella, un indicador clave de éxito será cuando muchas personas y empresas estén utilizando nuestros modelos para satisfacer sus necesidades de inteligencia espacial, lo que representaría un hito importante en su misión. Además, menciona que este viaje hacia la comprensión y aplicación de la inteligencia espacial es un proceso continuo y evolutivo, comparándolo con la complejidad del universo. El éxito no se mide simplemente por alcanzar metas específicas, sino por el impacto real y el despliegue de sus tecnologías en diversas aplicaciones. Fei-Fei Li enfatiza que la verdadera magia de la tecnología radica en su capacidad para abrir nuevas posibilidades, sugiriendo que su camino podría llevar a descubrimientos y aplicaciones que aún no pueden imaginar. ¿Qué aplicaciones prácticas de la inteligencia espacial creen que podrían tener el mayor impacto en nuestra vida cotidiana, más allá del gaming y la realidad aumentada? Mejor mira este vídeo sobre lo que piensa Sam Altman sobre el siguiente nivel alcanzado. Si has llegado hasta aquí en el vídeo, quiero darte las gracias, déjame saber lo que piensas en los comentarios, dale like, suscríbete y no olvides activar la campanita para no perderte ninguno de nuestros vídeos, no te cuesta nada y nos ayudas un montón. Esto es IA Avanzada y nos vemos en el siguiente.